Hello everyone, I am Vinny Teja, lecturer in chemistry, SKR and SKR Government College for Women, Kadapa. My topic for today's presentation is thermodynamics. In this presentation, I am going to focus on introduction of thermodynamics and its significance, different terms involved in thermodynamics, and lastly on laws of thermodynamics. Thermodynamics is the branch of science which deals with the relationships between heat and other forms of energy such as mechanical, electrical, or chemical energy. In the name thermodynamics, thermo means heat, dynamics means motion. Thus, thermodynamics deals with the relationship between heat and the motion of matter. Thermodynamics finds many applications in our day-to-day life. Now let us see some importance of thermodynamics. It is useful to predict whether any chemical reaction can occur under specific conditions, and useful to understand whether a reaction is exothermic or endothermic. It is also useful to understand the direction of spontaneous chemical change and to understand the mechanism of certain chemical reactions, and also useful to understand how a chemical or physical change responds with change in temperature and pressure. To understand the concept thermodynamics, we need to be familiar with certain terms which are involved in it. Let's see one after the other. The very first term involved in the thermodynamics is system. Any specific portion of the matter or universe which is under study is considered to be a system. Here I have given one image, a system which is present in the dotted lines. If we are observing this portion which is under dotted lines, it is considered to be a system. And the remaining portion of the system, or remaining except the system, the remaining portion of the universe is considered to be surroundings. Hence the surroundings is defined as the remaining portion of the universe. So the universe is nothing but system plus surroundings is universe. And these system and surroundings, they are separated from one another by a real or imaginary boundary through which matter and energy can flow into it, or flow from system to surroundings and vice versa. Depending on the transfer of energy and matter between system and surroundings, systems are of different types. They are open system, closed system, isolated system. A system which can exchange both matter and energy with its surroundings is called open system. Example, hot water present in an open beaker or vessel. This open vessel can transfer both heat energy as well as matter from the system to the surroundings. A system which can exchange only energy but not the matter with its surroundings is considered as closed system. Example, hot water present in a closed beaker or a vessel. If we touch the hot vessel, we can feel only energy but not the matter or any hot water coming out of the vessel. Such type of systems are called closed systems. A system which can exchange neither energy nor matter with its surroundings is considered to be isolated system. Example, hot water or tea or coffee present in a thermos flask is considered to be isolated system. And coming to next terms, they are state of a system. We come across the word state of a system in thermodynamics. It is the condition of the system which is described in terms of certain measurable properties such as temperature, pressure, volume, etc. The properties of the system such as temperature, pressure, volume, when changed during the process, the system also changes. These properties are called state variables. When a state of a system changes, then it is said to be that a process is happening in a system. For example, in a system, first and last process are called initial and final process. Let us see some of the thermodynamic processes. They are Isothermal Process, Adiabatic Process, Cyclic Process, Isobaric Process, Isochoric Process. Isothermal process is a process in which although heat enters or leaves the system, yet the temperature of the system remains constant throughout the process. That means there is no change in the temperature throughout the process. If we see in this image or in a graph, in the initial stage, stage 1, the variables are P1 and V1. And in the final stage or stage 2, the state variables are P2 and V2. But throughout this process, temperature is constant. Such type of processes are called isothermal process. Change in temperature is considered to be 0. There is no change in the temperature throughout the process. Adiabatic process is a process in which no heat enters or leaves the system during any step of the process. That means there is no heat. Q is equal to 0. Next, coming to cyclic process, a process during which the system comes to its initial state through a number of different processes. For cyclic process, change in internal energy, that is dE is equal to 0, and change in enthalpy dH is equal to 0. If we see in this graph, if we consider this as the initial step, it involves in many small processes to come again to the initial step. Such type of processes are called cyclic process. A process during which pressure remains constant throughout the process is called Isobaric process. Here there is no change in pressure. dP is equal to 0. A process during which volume of the system remains constant throughout the process, such processes are called Isochoric process. For Isochoric process, dV is equal to 0. Next, let us move on to the laws of thermodynamics. There are 4 laws of thermodynamics. They are Zeroth Law of Thermodynamics, First Law of Thermodynamics, Second Law of Thermodynamics, and Third Law of Thermodynamics. Zeroth Law of Thermodynamics states that when two bodies A and B are separately in the thermal equilibrium with the third body C, they in turn are in equilibrium with each other. For example, if A and B are in thermal equilibrium with another body, that is C, then all the three bodies A, B, C are in thermal equilibrium with each other. This is called the Zeroth Law of Thermodynamics. First law of thermodynamics states that energy can neither be created nor destroyed, although it may be converted from one form of energy into the other form of energy. Hence, the total energy of the universe remains constant, even though it may undergo transformations from one form to the other. First law of thermodynamics mathematical formula is delta U is equal to Q plus W, where delta U is equal to change in internal energy, Q is nothing but heat energy, W is equal to work done of the system or by the system. Next, second law of thermodynamics. It tells about all spontaneous or naturally occurring processes are irreversible. That means without the help of any external agent, a spontaneous process cannot be reversed thermodynamically. For example, water flows spontaneously from higher level to the lower level, but reverse process is not at all possible naturally. If we want to make it happen, we have to take the help of an external agents. Next, third law of thermodynamics. It states that the entropy of all perfectly crystalline solids may be taken as zero at absolute temperature. Entropy is nothing but it is stated with the letter S. S is equal to 0 at 0 kelvins. If we increase the temperature, entropy also increases. In this picture, A at temperature 0 Kelvin at absolute temperature, entropy is equal to 0. W is nothing but probability, thermodynamic probability. It is only single probability can be observed. This is a crystalline solid, perfectly crystalline solids. If we increase the temperature, the entropy is increased. So, above absolute temperatures, entropy also increases. This is nothing but third law of thermodynamics. So, in this presentation, I have focused on basics of the thermodynamics, which involves the definition and its significance, different terms which come across in the concept thermodynamics, and also there are different laws of thermodynamics. So these are the points I have discussed in this basics of thermodynamics introduction. Thank you very much.